Hi, this is Aviva Rothman. I'm a member of the History Department, and I was a Glennon Fellow for this 2019-2020 year. And I want to talk to you a little bit about the course that I proposed and developed and then taught this semester on the Copernican Revolution. So let's just click here. The idea of the course was based on a book that I'm writing, an anthology of primary texts on the Copernican Revolution for the Penguin Classics series. And my hope was that in selecting materials and then reading them with my students, I would have a better sense of what might work and what might not work for the volume, and then produce a better volume in the end. For the course itself, my goal was to first just tell the story, the scientific story of the Copernican Revolution to the students, help them understand what was at stake astronomically, physically, mathematically. Second, to show them that ideas like heliocentric theory or any other scientific idea can't be fully understood unless we situate it in its historical and cultural context. Third, to help them better understand history of science as a discipline, to show them the ways that science itself in its meaning and its methods and its goals changes and has changed over time. And finally, to bring together diverse types of students in the class, in particular students from the sciences and engineering and the humanities, to bridge the two cultures divide, or on our campus, the Euclid Avenue divide, and show them the ways that the material of the class might speak to all. So the basic timeline of the course was pretty traditional. Let me just move this so you can see. We started with ancient astronomy and set out what the ancients saw, how they saw it, what it meant to them, worked our way through Ptolemaic astronomy, medieval Islamic and Latin astronomy, hit Copernicus in 1543, and his book arguing that the sun was at the center of the cosmos, heliocentrism rather than the earth, geocentrism, moved through some theorists who read his work and either accepted, modified, or rejected it. Tycho Brahe, who developed his own geoheliocentric theory, Giordano Bruno, Kepler, Galileo, Descartes, and Newton. But what I tried to do in the class beyond hitting the major figures of the story is show students different ways that we might appreciate the story. So just a couple of examples to show you what this means. First, we did a lot of close readings. So just a couple of examples of that. We spent 2 whole classes reading 3 short selections from 3 texts from 1540 to 1543. One text by Rheticus called The First Narration. Rheticus is a student of Copernicus, and he publishes the very first account of heliocentric theory, even before Copernicus has published his book. Second, some selections from the famous Copernicus book on the revolutions of the heavenly spheres. And third, the short preface that was appended to Copernicus's book. Anonymously, although it turns out it was written by another astronomer, Andreas Osiander, whose views differed pretty profoundly from those of Copernicus. So we read all these 3 texts closely, figured out what assumptions they were making, how they argued the theory worked, what its advantages were to them over the alternative options, what they thought about the theory itself. Is it true? Is it physically real? Is it just mathematical? Is it just instrumental? And any other claims they made. And then we stepped back from all of that and said, if we were reading these texts in 1543, would we have been convinced? Would we have decided that Copernicus was right, or that heliocentric theory was right, or would we have stuck with the traditional option? And it turns out it's not obvious. The students were divided about this. There are logical ways to go in both directions. Another example is we read a bunch of letters from the 17th century, a lot of letters between Kepler and Galileo, and we talked about the process of letter writing back then, what it might be analogous to today, either journal writing or participating, sharing observations in a lab or something like that. Talked about how information traveled back then, why they're writing to each other, why they're writing in the ways that they are. So I think it was really interesting for the students to see early modern letter writing as a scientific genre. Another thing we did is we did a bunch of activities. I'll just pull them all up right now. Here are just a few examples, but the point of these was I wanted to give the students some hands-on ways to interact with the ideas we were talking about, especially for the scientists and engineers in the class who are maybe less used to close reading of primary sources and more used to playing with objects or manipulating numbers. So one example at the start of the class, we talked about the ways that astronomy is linked to the calendar, the lunar and solar cycles, and how they're different. And we developed the 19-year lunisolar cycle, the ways that the lunar cycles and the solar cycles are coordinated in a calendar, and then did the math to better understand why it is that by the time we hit the 16th century and Copernicus, the vernal equinox is 10 days off from when it should be. Another thing we did is we looked at the Copernican system and talked about how under Ptolemy, there's no way to tell what order the planets are in. Each planet just has its own individual model. But with Copernicus's system, you can actually figure out the order of the planets from the sun. So we played with the math for that and figured out the planetary orders. When we hit Kepler and his cosmic vision built on the 5 platonic solids, you see that picture at the bottom of the slide, the students actually built the platonic solids in class and then played with them and better understood what he was doing and what they meant to him. When we hit Kepler and his theory of cosmic harmony, we listened to audio recordings of what each planet would have sounded like and what they would have sounded like together as they're moving and what that all meant. And then just one final example, when we hit Galileo's telescope, we used some software to play with models of what Venus should look like and what its phases should look like if either the Earth is at the center of the system or the Sun is at the center of the system. We then compared the data from those models to the drawings that Galileo took when the drawings that he made when he actually looked through the telescope. We figured out why he thought the heliocentric theory was correct and what that meant based on the observations. We went on some trips. We went twice to the Cleveland Museum of Natural History. We looked at the telescope that they have there. And they also put together a couple of shows based on the themes of our class. They put together one show on geocentric astronomy to show students what your average observer before Copernicus would have thought and why. And they also put together a whole show on the telescopic discoveries of Galileo. They showed us the moon, what he would have seen and what it implied to him. And what I thought was most exciting is they put together his observations, his telescopic observations of the moons of Jupiter. So they showed us 2 months, sped through of what he would have seen in 1610 looking through his telescope and how he interpreted that to come to believe that what he was seeing were actually 4 moons circling around Jupiter, which was not at all obvious at first. A couple of final things we did in the class. So first, we didn't just look at the theories themselves. We looked at the ways that they affected the art and literature of the time. We looked at some frontispieces of texts to see artistic depictions of the history of astronomy and debates between Ptolemaic and Copernican theorists. And we played with these images and tried to interpret them. And we also read some 17th century literature that incorporated the ideas of the Copernican Revolution. We read, which is 2 examples, Godwin's The Man on the Moon, selections from that, Fontenelle's Conversations on the Plurality of Worlds, and we used these texts to better understand how popular writers were themselves understanding the theory and how they were helping a wider audience understand and accept the new theories. Read Milton and John Donne too, as just some other examples. And finally, I asked the students to pick and research astronomical instruments. Some worked on sundials of various kinds, some worked on quadrants, some on astrolabes, one on an armillary sphere. And the idea of this was that they would write papers on these instruments, on their history and use, and then we would all go to ThinkBox and they would build 3D versions of these instruments that they could play with and present to their classmates. We weren't able to do that final part because we had to leave campus beforehand, but the students did put together video presentations of their research, and some of them even built do-it-yourself models of these things at home and included that in their video presentations. So even though we were forced to leave campus at the end, I think it was a successful course overall, and I had a lot of fun doing it. Thank you. Figure out how to close this. There we go.